All right, guys, so we are moving on to still continuing with radicals, but we are actually going to perform some operations with the radicals. Namely, the first thing we're going to do is add and subtract radicals. Okay, so there's really two steps to adding and subtracting radicals. Step one is to simplify all radicals in the problem. Okay, so you have to make sure all the radicals are simplified first. Okay, once you simplify all the radicals, then it's just going to be a matter of combining like radicals. Just like combining like terms when we do the same thing. So by like radicals, we mean you can combine radical 2's with other radical 2's. You could combine radical 5's with other radical 5's. It means they have to have the same number under the radical to add them. Okay, so like if you look at this first example, I'm supposed to add radical 45 and radical 20. I can't because they don't have the same number under the radical. I am not allowed to add a rad 45. It's like trying to add an X and a Y. You can't do it. Okay, but the one thing you'll notice is that rad 45 and rad 20 are two radicals that can be simplified. Okay, so remember, when we're simplifying radicals with numbers, we need our list of perfect squares. Again, we could put them on the side here, right? So it's rad 4, right? That's 2 times 2, 3 times 3, 4 times 4, right? Make all your perfect squares. 5 times 5, 6 times 6. So 49 is 7 times 7, 64, 81, 100. We could keep going, but usually we don't really need much more than this. So remember, the way we simplify radicals is we want to break down the numbers. So I want to break 45 into a multiplication of two numbers where one of them is a perfect square, right? So if I look at this list of the numbers, only one of these numbers goes into 45 and it's 9, okay? So I could break it down into 9 and 5. Now remember, if you can't figure out what multiplies to be 45, if that's where you're having a hard time. So remember, we talked about how you could do it on your calculator, right? So you could type into your calculator 45 divided by X, and then go to your table and just look on the table until you see a perfect square, whole number. Like here's 15, but it's not a perfect square. Do you see there's that 9? So 9 times 5, that's the one you want to use. You keep scrolling until you see the one on this list. Okay, so that simplifies to be 3 rad 5. Okay, so do the same thing with the 20, right? You want to break down 20 into two multiplications. Again, you could still use your calculator one more time. You would do 20 divided by X. Go to the table and scroll down here until you find a perfect square. So it's right there. It's 4 and 5. Okay, so I'm going to put the perfect square first and then the leftover second. The square root of 4 we simplify to be 2. Okay, so now that I have these simplified, now instead of adding rad 45 and rad 20, what I'm really trying to add here is 3 rad 5 plus 2 rad 5. Okay, which I am allowed to add because they're both radical 5s. Now, when you combine like terms, okay, you can add to this if you want up here. You only combine the numbers in front. Okay. You only combine the numbers in front. So in this case, all I'm going to combine is the 3 and the 2, and I get 5, and then I'm just going to bring down the rad 5. It's like when you combine 3x and 2x, you just get 5x, right? The x doesn't change. Same thing here, the rad 5 doesn't change, okay? So you're going to simplify, and if they have the same radicals, you combine them. If they don't, you just leave it alone. It means you can't add, okay? So we're going to move on to this next one. So I have here. So remember, when there's a number in front, you just bring it down. Now, if you break down 8, 8 breaks down into 4 times 2, where 4 is a perfect square. The square root of 4 is 2. So remember, this is where the number in front actually does something in the problem. Do you see now you can multiply these two numbers in front to get 6 rad 2. Right? Then you're going to bring down your minus. Again, it doesn't matter whether it's add or subtract. It's the same two steps. 18, again, if you need your calculator, that is fine because there's a bunch of stuff that multiplies to be 18. So remember, 18 divided by X, you could go on your table, bam, right there. 9 times 2, 9 is a perfect square. Square root of 9 is 3, right? So this just simplifies to be 3 rad 2. So now that they're simplified, I see they're both rad 2s. So I'm just going to combine the numbers in front to get 6 minus 3 is 3, and I get 3 rad 2. Okay, so that's all it is. It basically is just, we're just simplifying still again. And then it's a quick combining like terms after. Okay, so here I have a lot of stuff to simplify. It's fine. It doesn't matter how much stuff I have to simplify. Starting with the 12, again, I could use my calculator, I could use my head, but if I'm picking the stuff that multiplies to be 12, I want to go with 4 and 3 because 4 is on my list. So this is going to simplify to be 2 rad 3. Okay, then I move on to my next one. Remember, this 2 in front comes down. And then I think of, okay, let me break down 10. Well, even if you're like, I'm not sure, if you did it on your calculator and you do 10 divided by x, when you scroll down, you have 10, you have 5, you have 2, and then that's it. Then you start, that's the rest, once you get to 1, that's all it is for whole numbers. So actually 10 is something that is actually already simplified. So don't worry about that one, just bring it down. You don't have to do that one, okay? Nothing more to be done with that one. Here, you're gonna bring down the 3, 27 can be broken down. So again, using my list, it can be broken down into 9 and 3. Now this 3 in front is gonna multiply what I get when I square root 9, which is 3. And then I bring this down as 9 rad 3. Okay. Then finally moving on to 40. 40 is something that can be simplified. Again, if you are using your calculator to help you out. Okay, if we do a little 40 divided by x. Okay, start up at the top. Sorry. Okay, so here, not a perfect square, not a perfect square, not a perfect square. It looks like, whoa, I might not get one until I keep scrolling. I had to go all the way down to the 4, okay? But once you go all the way down to 1, if you don't find it, there is none, okay? But since I did hit it, it is 4 times 10. So then that, I'm just gonna simplify to be 2 rad 10, right? Because that's a perfect square, that can simplify to be 2, okay? So now I'm looking at this and I say, all right, let's combine like terms. Now notice they're not all like terms. I have a couple that have rad 3s in them and a couple that have rad 10s in them. Remember, I can only combine the like radicals here. So I can combine the 2 rad 3 and the 9 rad 3. Okay, so if I just combine in front, 2 minus 9 is negative 7. And then I can combine the 2 rad 10 and the negative 2 rad 10. Now, if I combine in front, do you see, so this one and this one, but 2 minus 2 is 0. So technically it's 0 rad 10. So you don't have to write 0 rad 10, it's 0. These cancel each other out and I only get that as an answer, okay? All right, so why don't you try this last one right here? So this is rad 50 plus 3 rad 28 minus 2 rad 7 plus 32. Okay, let's see what you got. Okay, so for rad 50, okay, if you're breaking this down into 2 radicals, you have radical 25 times radical 2. The 25 is perfect. So that is 5 radical 2. Here I have a 3 in front, and then rad 28 breaks down into 4 and 7. This 3 comes down, this 4 becomes 2. So now I have a total over here of 6 rad 7. Okay, now minus this, I can't simplify, so I'm just going to bring that down. There's nothing you could do with 7. The only way you can break down 7 is 7 and 1. There's nothing to be done. Now 32 can be 16 and 2. Sorry, 16 and 2. When I simplify the 16, I get 4 rad 2. Okay? So just like before, we're going to combine what we can combine, which is a 5 rad 2 and a 4 rad 2. 5 plus 4 is 9. Remember, don't do anything with the rads, just bring them over. And then I could also do a 6 rad 7 minus 2 rad 7. 6 minus 2 is 4. Okay, final answer. Okay, so you just simplify and combine like terms. Okay, the only other thing I want to do with adding and subtracting is just bring in some radicals. Okay, so remember with the radicals, okay, I'm sorry, I want to bring in variables. Remember with the variables, okay, so if it's an even exponent, it's a perfect square and you can simplify it. If it's not even, remember you're going to drop it down and make it even, okay? So we're still going to do the same thing. We're just going to look at each radical separately. So like for number 5, I have a 2x in front and then I have a rad 12. So my question is, can I break down rad 12? Now you'll also notice that a lot of these numbers start repeating themselves a lot. So we've seen rad 12 before, which is great, okay? So here, rad 12 is going to break down into 4 and 3. So now I'm going to bring down the 2x. This square root of 4 now becomes just a plain old 2. Technically, it's times 2, which means I can multiply this 2 times 2 to get 4x rad 3, okay, for that one. Over here, I'm going to look at this and go, okay, so rad 3, I can't do anything with rad 3, okay, but x squared is a perfect square, okay, because it's even. So remember, if you see an even in there, get rid of it. This becomes x on the outside. Since I can't break down rad 3, I'm just going to leave it rad 3, which is great. I want it to be rad 3 because I have a rad 3 plus a rad 3. So again, all I'm going to do is combine the numbers in front, which happen to have x's on them, but it's no big deal. Add 4x and 1x, and you're just going to get 5x as your final answer. Okay, so sometimes you can simplify stuff, sometimes you can't, okay? All right, in the next one, I have an x in front, so I'm just gonna bring it down, okay? And then I'm gonna look at the radical. So the one thing you'll notice is you got a 4, square root of 4. Remember, anything that's perfect, you can square root it right away. The square root of 4 is 2, so I'm just gonna bring a 2 out here with that x. I just put it in front because that's normally what we do with it. Now, what's left over is just an x. Now, just an x I can't simplify because it's x to the 1. I can't break it down anymore. So I'm just going to leave it in the radical. It's not even, so I can't cut it in half. Since it's already down to x to the 1, that's as simple as it's going to go, okay? Now I'm going to move on to this radical over here. So I have a 3. Now, x to the 3rd, that's odd, right? So that means it's not perfect. I can't square root it right away, okay? But remember, with the odds, we just drop it down 1. So I'm going to drop this down to x to the 2 and x, okay? Then I'm going to simplify. So then this I can cut in half because it's even. It just becomes x, and that stays rad x. So now I look at this and I'm like, okay, I kind of know I'm on the right track because they're both rad x's, which means I can add in front 2x plus 3x is 5x. These can get a little more complicated with the letters in here, but we more focus on the ones with numbers, not as much the ones with letters, okay? But you will have some mixed examples with letters, with numbers for your assignment. Okay. All right. So now this one, again, getting a little crazy with 2 letters. Okay. Let's just, again, look at everything separately first. Don't worry about this. Just worry about the first radical. So 8, I know I'm going to have to break down. M, it's just m to the first. I can't do anything with it. N squared is perfect. Let's simplify it. N squared, I can cut in half to an n right away. Okay, then I'm going to worry about simplifying the other stuff. So anything perfect, just square root it immediately and get rid of it. Now, 8 is where I can, again, if I consult my list, 8 would break into 4 and 2. Now the m, since it's an m to the first, we can't do anything with it. Since it's not perfect, I'm going to put it with the 2 because that's also not perfect. Then I'm just going to finish. The square root of 4 is 2. Bring that down with the n. And I get 2n rad 2m. Oof, it's a mouthful, okay? Now we're gonna look at what happens over here. So again, I look inside the rad, not perfect, not perfect. So there's nothing I can simplify right from the beginning. I'm gonna bring down this 2n, okay? And then I'm gonna break down the 18. 18 breaks down to 9 and 2. And then just like before, I can't do anything with an m to the first, okay? So I'm just going to bring it down as an m, okay? Square root of 18 is 3. So I have 2n times 3, rad 2m. So when I combine that, that becomes, I can multiply the 2 and the 3 to get 6n rad 2m. Okay, so now I have 2n with a rad 2m, a 6n with a rad 2m. That's great. I can add the numbers in front to get 8n rad 2m. Okay. All right, so this final one I'm going to do with you, because like I said, we're more concerned about the ones with numbers than we are with the ones with letters, even though we'll give you some letter ones to try. Okay, so again, if I look at, I'm not going to worry about the fact that there's 4 radicals here. I'm just going to worry about each radical at the time. Okay, so if I look at the number, 9 is a perfect square. The square root of 9 is 3. Let's get it out. Now, x to the 5th is not a perfect square. So remember, the way we simplify the odds is to drop it down 1 with a leftover, right? So then here, I'm going to get square root of this is x squared, right? Cut it in half and I get x squared. So I get 3x squared rad x, okay? Now I'm going to move on to the next one, okay? So the next one, again, I have a 2x in front. I'm going to bring down x to the 3rd, also not perfect because it's odd, right? So that's going to break down into x to the 2 times x, right? You drop it down 1 with a leftover x. Now this, cut it in half and I get x. But now I already have a 2x. Remember, it's always technically times. So can I multiply these? Yes. 2x times x ends up being 2x squared rad x. Okay. Now let's go on to the next one. That does say 5 there. Okay. So I'm going to bring down the 4. I'm going to break this down into x to the 4 and x. Okay. Simplify x to the 4 and I end up with x squared rad x, right? So remember, we're going to just cut that in half and it becomes x squared. Okay, then the last one, okay, so this is a 2 here, right there. Okay, so the last one, I look at what I have to simplify. All right, 25 is a perfect square, right? So that becomes 5, right? So now I have 6x squared times 5. Okay, this x, I can't do anything with it because it's just x to the 1, okay? So notice out here, I have a little bit of multiplication to do, and I get 30x squared rad x, okay? Now I look at all my rads. The one thing I'll notice about all my rads at the end, after I simplify, do you see they're all the same rad? They're all rad x's, which means I can add everything in front. So I'm going to add 3x squared plus 2x squared is 5x squared, minus 4x squared is 1x squared, plus 30 is 31x squared rad x as our final answer. Okay, so the variables can get a little more challenging. Okay, my concern is more that you can handle the number ones. Alrighty?